In this lesson, we are going to go over some various properties of circles, all of which actually I think will be new to you. So at the start of your note here, you've got just a quick review of some terminology. Now there is written definitions for these terms in your workbook as well at the start of this section. But I've given you sort of a graphic here to help sort of summarize where these different lines would be found inside a circle. So a diameter, of course, is a line running straight through the center of your circle from one side to the other. The radius, of course, is the distance from the center to the edge of the circle. A tangent line is a line that would only touch the edge of your circle in precisely one spot. A secant is a line that travels through your circle and intersects it at two spots. And a chord is any point is a line segment joining any 2 points on your circle. Now we just need to add a couple of quick definitions here to your note. The first one is the definition of a segment. So a segment is the area that is created when you between a chord and the edge of your circle. So that would be this area right in here, okay, is referred to as a segment. And the area created with two radiuses of your circle, this area in here in other words, is called a sector. Okay, so those are some terms we'll be referring to in this lesson as well. So you've got some formulas here. You do not need to memorize these formulas, but I've given you the formulas for the length of an arc, the area of a sector, and the area of a segment. So now you know what we mean by those terms. Oh, I think actually we didn't add arc to your picture, did we? So let's add that. An arc basically is sort of, if you were to look within this sector, let me grab the pen on your picture, the arc is this area along the edge of the circle right here, along the edge. So let's add that definition to your, that label to your picture. Okay, so, and in fact, in the first question, it's actually the arc length that we're looking for. So we've got kind of a lot on that picture at the beginning, so let's maybe draw a simplified version here. So in our question, excuse the bumpy circle, we have a central angle of 50 degrees in our circle. Okay, so we're finding the length of the arc across from that, so that would be right here, and the radius of this circle is 6. So we're trying to find the length of the arc subtended by that angle. So using your formula for arc length, this one here, the first one, we're going to plug in our radius and our central angle. So we'll plug in 50 degrees for theta. So it'll be 50 divided by 360 times 2 times pi times 6. So 50 times 2 is 100, times 6 is 600. So you could enter this into your calculator as 600 pi divided by 360. And that should give you 5.24. So therefore, the arc length is 5.24 centimeters. All right, in the next question, you're asked to find the area of the sector associated with that arc. So now, if we look back to your picture, we're looking then for the area of this whole sector in the middle. Okay, so we're going to use the formula for area of a sector then from the top of your note, so this second formula. So it says area is equal to your angle, so 50 degrees, divided by 360 again. But this time, okay, let's make that a little easier to see. Divided by 360. This time we're multiplying by pi times r squared, so 6 squared. So this time we've got 50 times 6 squared, which is 36, times pi all over 360. And that gives us an area of 15.7, and it would be centimeters squared. Okay, so length of an arc, area of the sector, and the last example deals with the more complicated formula that I gave you at the end there for the area of a segment, this one here. But in this question, we're actually looking for the radius. So you would apply this formula exactly the same way we did the other two if you were actually calculating the area. A little bit more complicated formula, but you still would just substitute in the numbers and use your calculator to figure out your answer. So I thought I would give you an example of going the other way, so using that formula to calculate the radius if you know the area. Okay, so I'm going to rewrite the formula here so we have it handy. So the formula we're using is the last one, so A equals 1/2 r squared times pi divided by 180 times theta minus sine theta. Okay, so in our question here, we're given the area, so we'll fill in our 12.5 on the left-hand side, and we're looking to find the radius. So we'll leave an r in there for now. And then within the brackets, we can fill in our angle of 65 degrees. Okay, so you're just going to have to be careful when you type this into your calculator. So I would start inside the brackets and type in pi times 65 divided by 180, subtract sine 65. So you should be able to type that in all at once. That gives you 0.228156, I believe. Then you could multiply by 1/2 on the right-hand side, which is the same as dividing by 2. So that would give us 0.11408 r squared. Then dividing by 0.11408 on both sides gives you 109.57. That would be your r squared value. Lastly, you'll take the square root of both sides, and so you end up with a radius of approximately 10.5 centimeters. Okay, and that concludes this lesson.